Hi everyone, I am Mary Nicole Azuelo, and for this video, we're going to learn about the measures of correlation. So these are the objectives for this video. So at the end of this video, or at the end of this lesson, you should be able to first define what is correlation, understand the types and the values of correlation. 3. Solve for Pearson product moment correlation. And 4. Solve for Pearson product moment correlation using computer. Now, let's begin our lesson. First objective, which is define correlation. So, what is correlation? Correlation is a tool used to measure the relationship between two variables. For example, we have variable x and variable y. So this correlation is used as a tool to measure the relationship of each other, or how are they related to each other, or how are they connected with each other. How does this variable affect the other variable, and vice versa. Correlation in statistics means the degree to which two variables move in coordination with one another. Earlier, we've talked that how they are connected or related with each other. In this another definition, it stated that correlation is a statistical term that describes the degree to which one variable how one variable is coordinated with another variable. So this variable is um, expanding or scaling higher, then this one may also scale higher or expand higher, or it's about the movement of these two variables, how they coordinated with each other. So that's the meaning of correlation. Literally, correlation means relationship. Okay? So in literal terms, can be literally translated as relationship. So traditionally, correlation has a value that ranges only from -1 to +1. So for example, we have here a Cartesian plane. This is when we talk about the value of correlation only ranges from the -1 to +1. Or if it's in the y-axis, -1 to +1. So for example, the value of the variable is 0.3. So 0.3 is located somewhere here, right? As we all know, 0 is in between -1 and +1. So 0 is still in the range of the correlational range. So if the value is 0.3, it is still within the range of the correlation. Okay, so that's how they identify traditionally. So these are the values of correlation. So earlier, we've learned that traditionally, the values of correlation ranges only from -1 to +1. So only the values that is within that range is what we call the correlational value. So in this table, this side are the size of correlation, and in this side is the interpretation of each size or the range. If the correlational value has a result of 0.90 to +1, it is interpreted as very high positive correlation. Or if it's -0.90 to -1, then it has very high, you just change the positive to negative correlation. So we just do it like that in the same for the rest of the sizes. So if it's positive 0.70 to positive 0.90, it means high positive correlation. Or if it's negative, then as long as it's within the 0.70 to 0.90, and it's in negative, then you just change the positive to negative. As the same with this 0.50 to 0.70, it means moderate positive correlation. If it's negative, moderate negative correlation. If it's 0.30 to 0.50, it has low positive correlation. Or if it's negative, then it has low negative correlation. And if it has 0.00 to 0.30, then it is a negligible correlation. So that's the values of correlation. As you can read on your screen, a value of perfect positive 1 and perfect negative 1 rarely occurs. According to that, a value of perfect negative 1, which is negative 1 from here, and then positive 1 rarely occurs. Why? Let me introduce to you the types of correlation. So we have here the perfect positive correlation and the perfect negative correlation, which what we talked about earlier is that both of them rarely occurs. A correlational value of positive 1 and negative 1 rarely occurs. So what is perfect positive correlation? Perfect positive correlation or perfectly positive correlation means that 100% of the time, the variables in question move together by the exact same percentage and direction. A positive correlation can be seen between the demand for a product and the product's associated price. The value of perfect positive correlation is positive 1. So for example, this is in the line here, which is the x-axis, this is the demand, and this is the price of the product. So as long as the price or the demand of the product increases, then the price of the product also increases. So as you can see, it's increasing similarly. If you plot it in a graph or in a line graph, this is how it would look like. Other examples of a perfect positive correlation between two variables is schools with high test scores also have high graduation rates. And of course, if the schools have high test scores, then of course the students that are studying in that school, they will graduate. Most of them. So the school will have high graduation rates. Another example, when enrollment at college decreases, then the number of teachers also decreases. Of course, if the number of students can only be handled by 1 to 5 teachers, then 10 teachers is not necessary. So the number of teachers will also decrease. If the number of students are only 50 or in total. Another thing is investing in professional development for teachers also increases overall student achievement. Of course, if the professional development of teachers are increased and they are trained to facilitate learning better, or they develop new strategies how to develop the learners, then of course the learners' student achievement will also increase. Last, becoming more involved with school activities increases students' self-esteem. So if a student became more involved with school activities and that student will get used to it, of course, that will also build the student's self-esteem. So that is an example of perfect positive correlation. Next is perfect negative correlation. Perfect negative correlation means the relationship that exists between two variables is also exactly opposite of all of the time. So in statistics, a perfect negative correlation is represented by the value negative 1. So it's opposite from the perfect positive correlation. Earlier, the perfect positive correlation is increasing, but this one is decreasing. We have an example earlier. This in this axis we have the demand for the product, and then in this y-axis we have the prices of the product. This is a perfect negative correlation. It means that it really doesn't have relationship at all. So for example, this is the value of positive 5, and this is the value of positive 10. So you can see that these are exact. This axis, this variable has low value, and this variable right here has a high value. So they are opposites from each other. This one has low and this one has high. Like this one. In this axis, we have this is the highest value in our axis. But on this variable, the x-axis, it is plotted within the lowest value. So you can see that the higher the variable's value is, the lower the lower the value of the other variable. This is what you can see in our illustration. So these two variables is exactly opposite all of the time. So that is the perfect negative correlation. Perfect negative correlation. The relationship for this example, a student who has many absences has a decrease in grades. The more that the student is how they call it, absent, then the more that his grade decreases. So this example will sound like it makes sense, but the keyword here is a student who has many absences. When we say many, then it has a lot, and if it's a lot, then it is has a huge value or it has a high value. Then when it has a high value, then it is increasing. So if it is increasing in number, the number of its absences is increasing, then the other variable, which is his grade, is decreasing. So it is the opposite of each other. Of course, if a student has many absences, then of course his grades will decrease. As we are discussing correlation, how they are related with each other, as the number of his absences increases, then his grade also will be decreasing. Next example is the more one works, the less free time one has. So as one increases in age, often one's agility decreases. If a car decreases speed, travel time to a destination increases. So that is the example of perfect negative correlation, which these variables are completely opposite each other. So that's the perfect negative correlation. Now we move on to the Pearson product moment correlation. So what is this Pearson product moment correlation? Pearson product moment correlation is this shows the linear relationship between two sets of data. So the keyword here is the linear relationship. So in simple terms, it answers the question, can I draw a line graph to represent the data? So that is the Pearson product moment correlation. It can be drawn in a line graph. So two letters are used to represent the Pearson correlation. The Greek letter rho for P, that is the Greek letter rho. It's written as P for a population, and the letter R for a sample. But in this case, we are using the Pearson product moment correlation R. So when is Pearson product moment correlation coefficient are used? So this is used to measure, of course, the two sets of data, the relationship of two variables. So the Pearson product moment correlations formula, let's break it down. So the summation of x, so this symbol right here is the summation of x, this one is the summation of y, this one is the summation of the products of x and y, this one is the summation of x multiplied to x itself or x squared, and the summation of y squared, because this one is the summation of y multiplied to y itself or y squared, and then n the sample size. Okay, so we are moving on to the third objective, which is to solve for the Pearson product moment correlation coefficient. So I'm going to give an example. Our example will be to find the relationship between age and glucose level. So Pearson product moment correlation has two variables that are different from each other, yet it somehow would have a relationship with each other. It would still have an effect on each other. The age is a nominal number, so the age can be measured with a whole number, and the glucose level needs specific tools to measure it. Okay? We can't count it by 1, 2, 3 with just our hands. The glucose level can be measured by specific tools. We're just gonna use it as an example how age and the glucose level is related to each other, or how are they affecting each other. To begin, let's find the value of the correlation coefficient from this following table. So we have the age as our x variable and the glucose level as our y variable. So in this table, we have the subject, right? Subject 1, 2, 3, 4, 5, and 6. So we have 6 subjects, 6 person. The first person's age is 43, next one is 21, next one is 25, fourth one is 42, fifth one is 57, and sixth one is 59. So the glucose level of this person is 99, 65, 79, 75, 4, and 87, and 81. So this column right here represents the age. This column right here represents the glucose level, which is our y variable. And this is the subject, which in this column is the subject, which are our people, or the persons, the number of subject rather. So how do we solve that? Before we get to the formula of the Pearson product moment correlation, we should make a table first. The first thing we're going to do is to plot the data in a table. So the first column should be the subject, the age, and glucose level or sugar level. The next one will be the values of x, y, x squared, and y squared. So x and y. In this column, the x and y are multiplied to each other. So x times y is equals to xy. 43 times 99 is 4,257. 21 times 65 is 1,365. 25 times 79 is 1,975. And so on. This column that are multiplied to each other is the result is inside the column of x times y. In this column, we have the x squared, which means that x is multiplied to itself. So it's 43 times 43 equals to 1,849. 21 times 21 is equals to 441. 25 times 25 is 625. 42 times 42, 1,764, and so on. These are the values of the rest. And for this column, we have the y squared, which is y value multiplied to itself. So 99 times 99 is 9,801. 65 times 65 is 4,225. 79 plus 79 is 6,241, and so on. So these are the values from x and y, the product of x, y, the square of the x, and square of the values from the y column. So from our table, we have these values. So these are the total numbers or the total values from these columns. So the summation of x is from this column. Summation means all of them are added to get the summation. So the summation of x, so 43 plus 21 plus 25 plus 42 plus 57 plus 59 is 247. The summation of y, which is 99 plus 65 plus 79 plus 75 plus 87 plus 81 is 486. The same is with the summation of xy. These values right here are added to each other to get the 20,485. Same with the x squared. These values are added with each other, so we got the 11,409. And this column, we have the summation of y squared, which these values are added to each other, and we have 40,022 as our summation of y squared. And for our n, which the sample size is 6 because we have 6 subjects. So that is our given, or that's our values. Now we can proceed to our formula. What we're going to do here is just substitute the following values, from our table, these values here, and then solve them. So what we're going to do is we have here the values. So this is the formula, right? The R is equals to the N summation of xy minus to the summation of x times the summation of y, and etc. So what we're going to do is just substitute them. So this is the values that we have earlier from our table. As you can see, this is the first step. Substitute everything. So 6 times 20,485, which is the value of summation of xy, and 6, 247, which is the value of summation of x, 486, the value of the summation of y, and as you can see here, 6 is the value of n, or the sample size, and then 11,409 is the summation of x squared, and 247 is the summation of x squared. That value will be squared, and then 6 times 40,022 summation of y squared, and 486 is the summation of y. And then the first thing you're going to do is multiply the parentheses. So 6 here, 6 times 30,000, 485, 247 times 486. So we have 6 times 20,485, we have 122,910 minus the product of 247 and 486, we have 120,042. Now for this one, we have 6 times 11,409, we have 68,454. For 247, for the square of the 247, we have 61,009. For 6 times 40,000, 22, we have 240,132. For the square of 486, we have 236,196. So after that, what we're going to do again is multiply everything. So we have 2,868 as the result of 122,910 minus 120,042. We have 2,868. For earlier, for this, we have 7,445 and also 3,936. When we multiply them, we have 29,303,520 and also 2,868 remains there. The next step would be to find the square root of 29,303,520. and 303,520. So what is the square root of 29,303,520? We have 5,413.27. So you divide that from each other. After dividing it, we have the value of 0.5298091542, or rounded up as 0.53. But what we're going to use here is the four values here, the 0 point until 10,000. Okay. So we have 0.5298 as the correlational value. So the value of the correlation coefficient from the following table is 0.5298. And the value of 0.5298, or for 59 or 52.98%, means that the variables have a moderate positive correlation. So why is it moderate positive correlation? And this 52.98% is multiplied to 100 so that we have the percentage. And then, why does it have a moderate positive correlation? Because according to this table of interpretation, we have, it is 0.5298. So 0.5298 falls in the size of correlation 0.50 to 0.70. It has a moderate positive correlation. So I hope you get that. That is how you solve for the Pearson product moment correlation. You just have to remember that you have to get those values. You plot it correctly on the table and then get the product of xy and then square it with each other, and then afterwards just substitute the following values you have from your table to the formula of the Pearson product correlation coefficient. So it's simple. It's really simple. What is more easy is looking for the correlational value using the computer. So for our last objective, solving Pearson product moment correlation coefficient using computer. So how do we do that? The first thing we're going to do is open Microsoft Excel, WPS spreadsheets on your computer. So this is the symbol of Excel, Microsoft Excel. WPS spreadsheets is already located in the WPS. So you just have to add tab and then click spreadsheets there. So let's focus on Microsoft Excel. So after opening the Excel, you wait for it and then create a blank sheet. And after creating a blank sheet, type the data as follows. So this is our example earlier. So in this cell, you type the subject, the 1, 2, 3, 4, 5, 6, and then the age on the next column in each cell, and that's in the column of for this cell. So type the data as like this. Next step is select any empty cell. Afterwards, after you plot it like this, so you have here the Microsoft Excel, subject, age as X, and glucose level as our Y variable. So what you're going to do is select any empty cell. So when we say cell, it is the box where you input the data. So this one is cell. And this here is the letters, and then here are the numbers. So when you click this cell, it is identified as A1. The cell will be named as A1 because of the A right here and the 1 right here. So you just need to, going back, after plotting the table, the data on a table, you just have to click a empty cell. So after clicking the empty cell, you have to click the function button. So the function button is right here. It's just above the letters. It is the symbol FX. So click that, and then a window will pop up just like this. And in this window, this is the search bar. As you can, maybe you can read it. Search for a function. So if you can find, the next step after clicking the FX is to look for the correl keyword for the correlation, or if you cannot, then you have to search correlation on the search bar. So this is the search bar right here. You can see it, search for a function, and then type correlation there. And if the correl is already here in the select a function, these are the other types of function, we have the keyword correl here. So if you already have that, just click that, or if not, you can search the correlation word in the search bar. Afterwards, for step 6, type the location of your data into the array1 and array2. As what I've said earlier, your data is inside a cell, and these cells have its names. So if your data is located here, then the 43, the value 43 is in the B2 cell. So you start with, as you can see, array 1, there is a colon between them. What you're going to do is just write the first cell, is just write the name of the cell of your first value. So we have here, our first value is 43. So write 43 in array 1, and then put semicolon, put the colon symbol, and beside it, write the name of the cell for your last value, which is B7. And you're going to repeat that too for array 2, which is our Y variable. We have C2 colon and then C7. Remember that you only have to input the first data and the last data and put a colon in between them. Otherwise, it won't work. Array 1 will have will have the second column, and array 2, you can have the third column, just where your datas are inputted. So remember, just first data, and then the colon, and then the last data on these arrays. And then you click OK. After clicking OK, the result will appear in the cell you selected in step 2. Right? Earlier, we selected an empty cell. After selecting an empty cell, we click the FX. After clicking the FX, we search for the correl, the keyword. And then if we don't have the keyword, we search for it on the search bar. And then after the search bar will appear, we will have, after we click that OK, we click the correl. And then we will have a new window that will that is where we're going to put the values, the array 1 and array 2. What we're going to put there is just the first value, and then we put the colon, and then the last value. And then after putting the necessary what is needed on array 1 and array 2, we click OK, and just like that, we now have the correlational value 0.52981, which is accurate, is the value we had earlier when we solved it by hand, right? It is also 0.5298. And as we have here, 0.5298 if you round that up. So that is how you get the Pearson product moment correlation coefficient using computer. And also in using it by hand, solving it by hand, you just have to substitute the values into the formula, and then you get this. Lastly, according to the meaning of the Pearson product moment correlation coefficient, right? The question there is, am I able to create a line graph from my data? The answer is yes. So as you can see here, the correlation between the two variables. So this one is the age, and this one is the glucose level. So as you can see in our line graph, the lesser the age, the lesser the value of the glucose level also. So here, age, it also has a higher level. In this age, higher glucose level, also higher glucose level. So from this graph, we can conclude that the age and glucose level has a correlation, has a relationship with each other. So the higher your age is, or the more you age, the more your glucose level increase. So I hope you understood my lesson. That is all for today. Thank you for listening.